Okay, class, this is a recording for graphing secant inverse. Alex wants to say hi. Alex, say hi.
Hi.
That's lame.
Hola.
All right, here we go. We're going to start with graphing regular secant first. So what I normally do is I make a T chart. Okay, so this is your input, which is X, and this is your Y, which is your output. Now secant, I want to think of it as cosine. So I'm going to do value for cosine and then do its reciprocal. Cosine of 0 is 0. No, I lied. Cosine of 0 is 1. The reciprocal of 1 is still 1. Okay, so cosine of 0 is 1. Reciprocal of cosine, which is secant, is still 1. Cosine of pi over 2, which is 0. So secant is going to be undefined. Cosine of pi is negative 1, so reciprocal is still negative 1. 3 pi over 2, cosine 3 pi over 2 is 0, so reciprocal is undefined. And your last input is going to be cosine of 2 pi, which is 1, and reciprocal is 1. Okay, so remember, secant is the reciprocal of cosine. So if you know the values for cosine, you're going to be okay. So I'm going to go 2 pi here to the right and negative 2 pi to the left. I will make each period an even interval. So each tick mark is worth a pi over 2. Then I go up 1, down 1. And I'm going to start with the asymptote, okay, which is a pi over 2. And then 3 pi over 2. That means all odd multiples of pi over 2, you have an asymptote. All right. Now, at 0, I'm going to make a dot at 1. But I know that secant and cosecants have parabolas. Okay, opening that way. So this one, I'm going to go that piece over here. Opening down, that piece over here. There you go. So as you can see, this is not a one-to-one because it's not going to pass your horizontal line test. And if you don't have a graph, then you can say, that, I'm trying to, ooh, I did it, I think. Sorry, I'm testing out something. If you don't have a graph, then you can say that, hey, look at this right here, right? You have one Y value, but you have two X locations. So that's another reason that it's not a one-to-one. Okay, so one-to-one means it doesn't pass the horizontal line test, or one input can only have one output. Okay, part 1, it's Y equals secant of X in one-to-one. The answer is no. Because your answer is no, we have to restrict its domain. Okay, so as you can see, if I restrict it from negative pi over 2 to pi over 2, it's not a one-to-one. So reject that idea. I'm going to restrict it from 0 to pi. That's better, right? Because this is half of a parabola, and then this is the other half, but it opens the other way. So as you can see right now, that's definitely one-to-one. So we need to restrict it so it can be 1-to-1. Well, we're going to restrict it inclusive, 0 all the way to pi. But as you can see, there's an asymptote in the middle, so X can never ever be pi over 2. Now another way of writing that is interval notation. 0 to pi over 2, take a break, pi over 2, all the way to pi. So let's go and define the inverse of secant. Now the inverse of secant, we're going to start with switching X and Y. So X equals secant of Y. By definition, I have to solve for Y, so now I'm going to compose both sides by secant inverse. So that means secant inverse of X equals Y, which is really, notation for inverse is F to the negative 1 power. We are now going to state the domain and range of secant inverse, and then we're going to talk about the quadrants. Okay. All right, so the domain of secant inverse, you have to look at the range of your regular, okay? So the range of the regular is from negative infinity to negative 1. So negative infinity to negative 1. Union that with, as you can see, 1 to infinity. So union that with, sorry, the 1 has to be inclusive. So 1 to infinity. That's your domain of your inverse. Now the range is the part that we restricted, right? So this is the restriction. That means that's where the range is going to be. So 0 inclusive to non-inclusive pi over 2, because that's what the asymptote was. And then from pi over 2 to pi. Now earlier we talked about quadrants, okay? Pi over 2, so 0 is right here. pi over 2 is right here, and pi is right here. So as you can see, secant, it's in quad 1 and quad 2. Okay, super important that we go and identify these quadrants. Which reminds me, I forgot to tell you about the quadrant and cosecant. So can you go back up to the notes and fill in the quadrants? Quadrants for cosecant, we talked about positive pi over 2 and negative pi over 2. So quadrants for cosecant is 1 and 4. Okay, 1 and 4. So cosecant 1 and 4 because cosecant is a reciprocal of sine and secant is reciprocal cosine, so they have the same restriction quadrants. All right, so now let's go and just graph the inverse and the restricted part on this graph to see if it's symmetrical. About beautiful line right here called y equals x, y'all. Okay, so I'm gonna go and label these y's, okay, as pi. Now 1 unit is a third of its distance. Okay, so because that's pi is about 3.14. So here's 1, here's 1, here's pi over 2, here's pi over 2. Okay, I'm gonna start with an asymptote. I'm going to graph y equals secant in red, and then I'll do another color for its inverse. So at pi over 2 asymptote, and 1 right there, negative 1's on the bottom, make that dot. So here's my regular secant restricted, okay, from 0 to pi. And then I'm going to go in and use rainbow. How about that? Y. Oh, it's frozen. Y equals secant inverse of x. So what I'm going to do is I'm going to switch the points. Okay, let me label the points for you. It's easier. 0, comma 1 is that one. So now 1, comma 0 is my mark. Notice how this curve right here is hugging the y-axis. So its inverse, I'm going to need to be hugging the x-axis, okay? At the same time, I should go in and mark my asymptote for the inverse. So I'm hugging the x-axis. I'm going to be creeping towards the asymptote. Now, the other one, this dot right here is pi, comma, negative 1. So I'm going to go and do negative 1, comma, pi for its asymptote. So negative 1 of pi. There you go. Okay. So again, I need to, this curve right here is going towards negative x, okay? That means I'm going to, negative y, my bad. That curve right is going towards negative y, okay? That means on my inverse, I need to be approaching negative x that way. So check it out. It totally is reflected over the line y equals x, right? This piece is reflecting with that piece, and then this piece is reflecting with that piece. So as you can see, okay, those are inverses of one another. And guess what? This is the end of our recording.